we've covered non-mutually exclusive, and the only thing that has is or. So that was very simple, very easy, not hard to do. But now we're going to go to the not mutually exclusive. And this is going to be when they occur at the same time. Two events happen at the exact same time. So with this, another vocabulary word is here because that's why it's in red. So mutually exclusive was one vocabulary word. Non-mutually exclusive was the second one. So let's go to example. Let's go move on to the next example, example 2. And again, this one we're talking about an or problem again. Or. But this time we're not talking about it happening this or this happening. We're talking about it pretty much happening at the same time. So we're talking about this or this happening, but it's pretty much talking about things happening at the same time, working together. And when I say that, you're going to see what I'm talking about. Because it's not just, oh yeah, this happening or this happening, blah, blah, blah. You'll see what I'm talking about. So let's go to example 2, and we're going to talk about a spinner. And again, I do want you to write this down. And stop the video, and then we'll go ahead and move on. So for example 2, the spinner is equally probable that the pointer will land on any one of the 8 regions numbered 1 through 8. If the pointer lands on the borderline, in other words, line right here or right here or here or here, if it lands on one of those, you have to spin again. So we're going to find the probability that the pointer will stop on a equal number or a number greater than 5. So about equal number or a number greater than 5. So these things are pretty much can happen together. It can be an even number that is greater than 5, or it could be in a number that's greater than 5 that's even. So it can happen out at the same time. Like that, both of those things can happen at the same time. So what is find the probability that a pointer will stop on an even number or a number greater than 5. So there's a bunch of those happening. So again, I'm going to highlight the part that we need to have, which is this last part. But I'm going to double highlight a piece, 2 pieces that are important. So those 2 pieces are pretty important. So when we do this problem here, and let me go pull my Elmo back up. So when we do our problem here, we're trying to find the probability of an event of even number happening or a number greater than 5. Okay, and so again here, this is considered event A, this is considered event B. And this one, things can happen at the exact same time. Like for the king and queen, you can't have a king and a queen if you're just selecting a card at a time. But here, you could have an even number and a number greater than 5 happening at the same time. It could happen. Okay, but the word is or in the middle, so therefore we have to use this one non-mutually exclusive because they could happen at the same time. So here, we're going to go ahead and take a look at all the stuff. So we know that we're talking about the or part. So that means the answer is going to look like this. So probability of A plus the probability of B minus the probability of A and B happening at the same time. Okay, so first things first. Let's take a look at A. How many even numbers are there in the whole thing? Like in our spinner right here, how many even numbers are there? So it's 1, 2, 3, 4 even numbers. So before we even do any work here, I'm going to put this down here. There are 4 even numbers. Oops, 4 even numbers. So leave space up here because that's going to be important for what we're going to do. Well, actually, let's go put it up here. Let's put it right here. For even numbers. Because that's event A. That's event A there. For even numbers. All right, so for event B, how many numbers are greater than 5? Greater than 5. Not 5 and more, but greater than 5. And so we should see that 6, 7, and 8. So there are 3 numbers greater than 5. Okay. Now, with that again, because we're talking about probability, how many numbers are there in all? You're always going to have to know how many numbers there are in all, or how many things there are in all. So, there are 8 numbers in all. There are 8 numbers in all there. So that's going to be the most important part there, so we can go ahead and put everything together. So, first off, the probability of having an even number. That's probability of A. So here, let's write this down. Probability of even. That means there's going to be 4 even numbers out of 8 numbers in all. 4 out of 8. All right. The second thing, probability of numbers greater than 5. So greater than 5. So our probability for that, there's 3 numbers out of 8. 3 out of 8. And then let's put addition sign right there. So there's 3 out of 8. Now the last thing is figuring out what is the probability. What's the probability of it being even and greater than 5? So what's the probability of that happening? So again, there's 8 numbers in all, so we're going to put that in the bottom. But how many numbers are even and greater than 5? So here we know these are numbers that are greater than 5. So of those 3 numbers that are greater than 5, 2 of them are going to be even, right? 6 and 8. They're both even. So 2. And so all we do now is just go ahead and add and subtract, and not alphabetical order, but in order of operations. Add then subtract here because the addition's first and subtraction. So when we do that, we get this part out. You don't need to see that part. We get 5 out of 8. And if we change that to a decimal, that's about 0.625 blah 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 blah. No, I think actually 0.625. Okay, so we change that to the percent. That's going to be 62.5% or percent chance that this could happen. Now every time, remember, whenever you're changing a decimal to a percent, you always move over 2 decimal places to the right. Always move 2 decimal places to the right. All right, and that's it. That's all we got to do. So when it has the or in it, if this can and this can happen at the same time, then you have to use the mutually non-exclusive one.